Hi everyone, this is the foundation video for the specific heat capacity question. So we've got a student investigated how the temperature of a metal block changed with time. An electric heater was used to increase the temperature of the block. The heater was placed in a hole drilled in the block as shown in figure 1. So this looks like the specific heat capacity required practical. You've got your metal block, you've got some insulation around it, you've got a heat resistant mat, you've got an electric heater connected to the power supply, and then you've got a thermometer to record temperature. The student measured the temperature of the metal block every 60 seconds. The table below shows the student's results. So you've got your time and your temperature. Okay, the time here is the independent variable, and the temperature is the dependent variable, the one that you measure, which is going to be important when we come to the question, which is completing a graph from the data from the table above. Okay, so if you flick to your scale, you can see that it's already plotted temperature for you. And we started at 20, we're going up in 2s all the way to 32. The first thing it's asking you to do is choose a suitable scale for the x-axis. Okay, now this one is our x-axis. Now whenever you're doing investigations, your independent variable goes on the x-axis. And our time here is already going up in equal steps, so it's going up in 60s. So the easiest thing to do would be to start from 0 and then go up in 60s. 60, 120, 180 and 240. Then it's asking us to plot this, label the x-axis. So this is time, and time is in seconds. Then it's asking us to plot the student's results and draw a line of best fit. They're very important, as these things are both numbers in each column. It means that we need to draw a line graph, so not a bar chart. First coordinate we need to do is 0 for our time and temperature of 20. So it's going to fit quite nicely there. Then we've got a time of 60 and a temperature of 24.5. So this is 24, this is 25. 24.5 is going to be in the middle of those. Notice that I'm doing quite a nice small little cross, not a big thick circle. At 120 we've got 29 degrees, which is going to be there, and at 180 we've got 31 degrees, which is here, and then at 240 we have got 31.5, so 31.5 is going to be there. Okay, then we need to draw a line of best fit. So not all lines of best fit in science are straight lines. You can see that this one's going to look like it's got quite a nice curve to it. The first part of the graph is straight, and then after about 120 seconds it starts to curve. So our line needs to try and be as straight as possible in those first 120 seconds. So using a ruler would be advantageous to make sure your line is straight. And then in the last part of the graph, mine's got slightly wonky, we will have a curved area. So your line of best fit will look like that. Yours will be straighter than mine here. So just double check that we have got everything that they want plotted. So we've got scale, x-axis, plot of the results, and we've got a line of best fit. Okay, so moving on to the next question. The rate of change of temperature of the block is given by the gradient of the graph. Determine the gradient of the graph over the first 60 seconds. Right, so for this one, what we need to do is draw ourselves a little triangle underneath the graph for the first 60 seconds. From maths, we should know that the gradient equals the change in y divided by the change in x. Or you might know it as rise over run. So if I'm looking at the graph, I can see that this point here is 24.5 and I started at 20. So to find my change in y, it's going to be 24.5, take away 20, which is 4.5. So that change is 4.5 degrees. Then I've got to do my change in x, so this one's dead easy. I've started at 0 and I've gone to 60. So that gives me a change of 60 minus 0, or 60. And to find the gradient, we're going to do the change in y, which is 4.5, divided by the change in x, which was 60, and it gives a gradient of 0.075 degrees C per second. Moving on to the next bit, we've got the metal block has a mass of 1.5 kilograms. The specific heat capacity of the metal is 900 joules per kilogram degrees C. Calculate the change in thermal energy of the metal during 240 seconds. Use a physics equation sheet. Okay, so I know you haven't got a physics equation sheet, but you should have seen from the video that there is an equation we use for specific heat capacity, which is change in energy equals mass times specific heat capacity times the change in temperature. The mass is told me is 1.5. The specific heat capacity is told me is 900. And the change in temperature for the first 240 seconds. So I need to go back to my data to get this. So in 240 seconds, I've gone from 20 to 31.5. That's a change of 11.5 degrees. So my temperature change is 11.5. You put that in your calculator, you'll come out with 15,525 joules. Now, if you've read the question properly, you'll see that it's asking for the answer in kilojoules. So to go from joules to kilojoules, you have got to divide that by 1,000. So I need to do 15.525, which will be my eventual answer. I've got that from dividing 15,595 by 1,000. So the change in thermal energy in kilojoules is 15.525. If you missed that bit and you forgot to change into kilojoules, you only got 3 marks for that 4-mark question. Another student repeated the investigation. Give 2 variables this student would need to control to be able to compare their results with the results in the table above. Okay, so control variables, it's asking you, what control variables do we need? We need to have the same mass of block. And we would also need to have the same material of block. There are also some other things that you could have. You could have the current through the heater. And you could also have the same insulation. And also you can have the same starting temperature of the block. So well done for completing those questions, and I hope it makes sense. Please email me, Miss Naylor, if you have any problems with this, and I'll be happy to explain it to you. Thank you.